The topic of my report is non-destructive test for macro damage, and in my report it includes three parts: eddy current testing, wave light transfer, and principal component analysis. Nowadays, in transportation, nuclear, and power fields, macro defect is a major cause of failure of engineering structure, which is easy to lead to disastrous consequence. So it's necessary for us to know whether there exists macro defect in advance. So non-destructive tests become a research hotspot because it doesn't affect the functional performance of the test object. And the first part is eddy current testing. Eddy current testing technology provides a unique and low cost of larger scale, high-speed detection method. It has been used in nuclear energy, marine high pressure, high temperature, and high-speed engineering systems. Eddy current heating and heat conduction can also get a temperature distribution on the surface of material, and due to the choice of the key characters of a pixel, it's very difficult to detect. So, in order to overcome the problem above, the image level of processing methods is brought to attention of the research. Independent component analysis, principal component analysis, and the wave-light transform start used to detecting the abnormal structure in sequence of heat maps. And the left picture is an original material sample. And because the macro damage is too small to see through the eyes, so we have already marked the macro damage by the circle, which are numbered from 1 to 7, and the left is a ECPT image. So the second part is wave-light transform. The multi-resolution analysis is based on the concept of functional space, which provides a simple ways of construction of the wave-light base. The intuitive understanding of multi-resolution analysis is that the signal can be analyzed according to the research-specific requirement. So the multi-resolution analysis method for signal analysis is more detailed and flexible. And the wave-light transform is usually used to denoising. So here are the basic steps for wave-light denoising. First, wave-light decomposition of a signal. Select the appropriate group and to determine the wave-light decomposition level and decompose the signal into n layers. The layers obtain the wave-light coefficients, and then solving the closing value. According to the layers of wave-light coefficients, the basic parameter estimates noise, and the signal itself and the noise parameter estimation solve threshold lambda threshold processing. Third, threshold quantization. Each layer of high frequency coefficients used to use a threshold value function in construction lambda, both threshold quantization, wave-light reconstruction. After dealing with the closing value of wave-light coefficient reconstruction, the signal by algorithm of wave-light transform. So here are two pictures. In first image is the original ECPT image. We can see there are so many spots in the image. And the second one is a ECPT image that has been denoised by the wave-light transform. The surface of the image in second one is much more smoother than the first one. So we can say wave-light transform is very good in denoising the white noise. And the last part of my report is about the principal component analysis, PCA. PCA is mainly used for data dimension reduction because the characteristic of the series of example of a multi-dimensional vector cannot be distinguished. So our purpose is to find those changed large elements, namely the variance of dimension, and to get rid of the little change. And the other advantage of PCA is that it has less amount of calculation. And here is the mailing steps in my report to extract the features based on PCA heat map theory. First, we input the original video film to get a three-dimensional information matrix, and then deal with original matrix for two-dimensional matrix, and we solve the covariance matrix, and solve the corresponding eigenvalue and eigenvector, and then we select the eigenvectors corresponding the mean eigenvalue. And we have to get the output matrix. And last, we have to reconstruct to the three-dimension original video matrix. That's the whole steps for us to extract the features based on PCA. Now here's the result of PCA. From the first image is the principal component of the first 128 image, and the second one is the principal component of first 129 image. From this image, we can clearly see that, for example, here the circle is indicate a macro damage that we have marked. And in the second one, we can also find the macro damage. And here is my programming, and I have run it, and here is my result. The first one, the original image that has various spots, and the second one is the image that has been denoising by wave-light transformation, and you see the surface of this image is much more smoother. And the third picture is the principal components of first 128. We can find the macro damage from the image. For example, here. And the last picture is the principal components of first 129. We can also find the macro damage here. So this is my report about the non-destructive testing.